So we decided to go with the Scotch yoke device because we wanted purely linear motion. And then we designed it out of acrylic to reduce friction because that's the main source of error from previous groups.
To mathematically determine the radius of the rotating circle for our device, we just went through some derivations. So we realized that the x position of the circle at any time was going to be equal to our radius times cosine theta, where theta is the rotating angle of the small point that will be moving the entire linear portion. By taking the derivative of this, we found that x would be equal to r omega sine omega t, and by taking the derivative of this function, which would have given us our velocity, we found our acceleration component, which would be negative r omega squared times cosine omega t. Recognizing that cosine is at its maximum when equal to 1, we recognized that our maximum acceleration would be when a equals r omega t, or r omega squared. So, recognizing that our maximum acceleration should be 9.8 meters per second squared, we took this number and divided it by omega squared, which we found experimentally, to find our maximum radius. This did give us correct results, and we ended up with a maximum acceleration very close to 1 g. It was about 1.1 to 1.3 g's. So all in all, our device worked pretty well.